Introduction. In the vast expanse of space, planets and stars are two fundamental celestial objects with distinct characteristics. Understanding the differences between them helps us better appreciate the diversity of objects in the universe and their roles in cosmic structures. While both planets and stars are crucial to our understanding of the cosmos, they differ significantly in their formation, composition, and behavior. Definition and formation. A star is a massive, luminous sphere of plasma held together by gravity. Stars form from clouds of gas and dust, known as stellar nebulae, which collapse under gravity to initiate nuclear fusion. This fusion process generates immense energy, producing light and heat. In contrast, a planet is a smaller celestial body that orbits a star. Planets form from the residual material left over after a star's formation, accumulating matter through accretion in a protoplanetary disk. Physical characteristics. Stars are characterized by their high temperatures and luminosity, which result from nuclear fusion in their cores. This process converts hydrogen into helium, releasing vast amounts of energy. The surface temperature of stars can range from a few thousand to several 100,000 degrees Celsius. Planets, on the other hand, do not generate their own light. Instead, they reflect the light of their parent star and have relatively cooler temperatures compared to stars. Their surfaces can vary widely, from rocky and solid to gaseous and icy. Light and energy emission. The primary difference between planets and stars is their source of light and energy. Stars emit their own light due to nuclear fusion, making them visible from great distances. The brightness of a star depends on its size, temperature, and stage of evolution. Planets do not produce their own light. They are visible due to the reflected light from their parent star. Their visibility and apparent brightness depend on their distance from the observer and the star they orbit. Composition. Stars are predominantly composed of hydrogen and helium, with heavier elements present in trace amounts. The core of a star is where nuclear fusion occurs, transforming these elements and producing energy. Planets have a wide range of compositions. Rocky planets, like Earth and Mars, have solid surfaces composed of minerals and metals. Gas giants, like Jupiter and Saturn, have thick atmospheres composed mainly of hydrogen and helium, with possible rocky or icy cores. Size and mass. Stars are generally much larger and more massive than planets. The smallest stars, known as red dwarfs, are about 10% of the mass of the Sun, while the largest stars, such as supergiants, can be several hundred times larger. Planets are significantly smaller, with their sizes and masses varying from small rocky bodies to large gas giants. The largest planets are still much smaller than even the smallest stars. Life cycle. Stars go through a life cycle that includes stages such as protostar, main sequence, red giant, and, depending on their mass, either a supernova or a white dwarf. This life cycle is driven by changes in nuclear fusion and gravitational forces. Planets do not have a life cycle in the same sense. Instead, they evolve over time through processes such as geological activity, atmospheric changes, and interactions with their parent star and other celestial bodies. Role in the solar system. In a solar system, stars serve as the central gravitational anchor around which planets and other objects orbit. They provide the necessary light and heat to sustain planetary environments. Planets, meanwhile, orbit the star and can have various characteristics that support or challenge the possibility of life. They contribute to the dynamic processes of the solar system through their gravitational interactions and potential for hosting moons, rings, and atmospheres. Observational differences. From an observational perspective, stars appear as points of light in the night sky, often with a steady, twinkling appearance due to atmospheric interference. Planets, by contrast, appear as larger, more stable points of light or disks, and their positions relative to stars change over time due to their orbits. The apparent movement of planets through the night sky, known as planetary motion, is distinct from the fixed positions of stars. Conclusion. While planets and stars are both essential components of the universe, their differences in formation, composition, and behavior are fundamental. Stars are luminous objects that produce their own light through nuclear fusion, whereas planets are non-luminous bodies that orbit stars and reflect their light. Understanding these differences enhances our knowledge of celestial mechanics and the diverse structures that populate our universe.